Hi there, this is Manish Kumar Gupta, and I'm here to present our work on reconstruction and repair degree of fractional repetition codes. This is joint work with my student Krishna Gopal Banerjee and Nikhil Agarwal, and currently we are at DICT Gandhinagar, and this is for the conference Netcod 2013 at Calgary. So this is a poster paper. So let me explain our work. So we are working in the area of distributed storage, uh, where and we are specifically looking at what is known as dress code, that is distributed replication based exact simple storage. So given a file, it is encoded using an MDS code, and then using an inner fractional repetition code, and then it is thrown into the cloud. And when user wants to reconstruct the file, it can contact certain number of nodes. And similarly, if a node fails, one can repair the node by contacting certain other number of nodes. For example, if you look at this picture here, there are a file is decomposed into 8 packets, and then using an MDS code, a parity packet 9 is added, and then in each of these 9 packets are duplicated across the 5 nodes in a very smart manner, so that if user wants to contact, if the user wants to reconstruct the file, he can contact any 3 nodes. In this case, you can see that I have if he connects to U1, U3 and U5, he can get 8 packets, and rest of the packet he can get by using the parity property. So K is known as, so these 3 nodes, so K is equal to 3. That means the reconstruction degree of the fractional repetition code is 3. In case of a failure of a node, suppose U2 is failed, so we lost packet 169, and you can see that you can get packet 169 by contacting node U1, U3 and U4. So you need to contact a specific set of nodes to reconstruct the entire data that was lost. So this is known as repair degree. So repair degree of the node U2 is 3. So in this work, now let me introduce our problem. What we have done, given a fractional repetition code, that means suppose we are given n nodes, and suppose there are theta packets, each replicated row times across the node in a smart manner. What is the reconstruction degree? How many nodes we need to contact to get the entire data, and what is the repair degree for each node? If the size of each node is same, then it is easy to compute the repair degree. Otherwise, it is a non-trivial problem, and that's why we have given our algorithm number 2 will compute the repair degree for each node. For the reconstruction degree, we provide an algorithm, but actually we provide an algorithm for finding the specific kind of reconstruction degree, that is known as K star. K star is defined as the smallest set of nodes that we need to contact to reconstruct the whole file. This is different from what is known as the actual fractional repetition, actual reconstruction degree of FR code, which is the smallest set of any nodes once contacted will reconstruct the entire data. So our first algorithm will compute K star. In fact, it will give an upper bound in general, but in our example here, it will give you the exact value. And the idea here in this algorithm is that we try to reconstruct the file by taking the maximum set and keep on adding packets one by one. And each time we add the packets, we actually update a counter, and that counter value will give us what is the reconstruction degree. So in this example that we started with, if you focus on in this example, we drop first of all, what we do, we drop the packet number 9. So we left with 8 packets, because this can be recovered by using the parity property, and we call this set as Vn in our algorithm, and here of course n is 5. Then we check if there are any sub nodes. That means if there are subsets, then we delete those subsets, because those subsets cannot contribute to the reconstruction degree. We can take the maximum, we can take the supersets. Since in this example there is no such case, we start with the same set and we call it as Vm. So Vm is when we deleted all the subsets, and here in this case of course Vm is equal to Vn, and of course n is equal to 5 and m is equal to 5 as well. So in this set, now we look at all those sets V1 and all those sets which are having maximum cardinality. So here V1 and V4 have maximum cardinality. We put it in another basket and we call it as, and you can see that V1 has V2, V3, V4. V1 has 1, 2, 3, 4, and V4 has 3, 5, 6, 8. Those packets are there. We call it this set in algorithm as VL, where L is equal to 2. Now we check. We take any of these nodes randomly and we put in a bucket P. So in this case, suppose we take V1, and so there are packets 1, 2, 3, 4. As soon as we put something in the bucket, we update a counter K1 that will actually compute the reconstruction degree. In this case, we have put one diamond here to showing that we have updated it once. So now, after this, we check if there is any node in VM which is which is disjoint from P. If that is the case, we actually add further here and update the counter. If that is not the, in fact in our case there is no such VM, so we actually drop this. There is no need to consider this. And so what we do now, we look at, is there any set Vi which is not a subset of P. Now if you look at in the example, because we know that P has right now 1, 2, 3, 4. So V2, V3, V4, V5 are the examples which are not subset of P. So we just subtract P out of each of them. So we subtract the packets of P from each of them to get what are the resultant packets that are left. So V2 minus P is 6, V3 minus P is 5 and 7, and so on. Now after this, we look at the maximum set, maximum packet, a set which is having maximum packets. So here in this case 5, 6, 8. We know that this is disjoint to P, so we add it to P and update the counter to 2, because so now we got the distinct packets 1, 2, 3, 4, 5, 6 and 8, and still we are so now we repeat this procedure, and again if we repeat this step, we see that packet number 7, because now this is deleted, so packet number 7 is there which is still not in P, so we add it to P when we repeat this, and we again update the counter K1, and this will give us the reconstruction degree K1 when we use set V1. In the same way, we can use another set V4 and we can repeat it as many times as we can find the maximum cardinality set, and each time we find the K1. So in this second time we call it as K2, and then we can compute the reconstruction degree as the maximum of these two things, and that is in this case is 3. So the reconstruction degree is 3, which we have already shown to you. Now the second algorithm is about computing the repair degree. So suppose this time our example has 4 nodes and there are 6 packets duplicated twice, and suppose node U2 fails. So if we want to reconstruct, so we want to repair the node U2, we want to put again 1 to 5 back. How we can do that? So we look at what is known as, first of all, we define what is known as, by looking at the node packet distribution incidence matrix, we look at, we call certain set which are supports. So packet number 1 is in U1 and U2, packet number 2 is U1 and U2, packet number 3 is U1 and U4, and so on. We construct this table, and now note that in order to construct U2, we need to see that the maximum repair degree possible is 3, because the alpha 2 is 3, because the total number of nodes, node size is 3. So we can get, now we will actually try to reconstruct how we can, so basically we want to see that, so basically if you construct node, if we contact node, so we know if you contact 3 nodes we can get the entire data, but we want to see if there is something common. So that thing is taken care by, if we actually come, so for example in this case we see that U2 is there in H1, H2 and H5. So we subtract U2, we get another set, and we so H1 minus U2 is U1, H2 minus U2 is U1, and H5 minus U2 is U3. This way we are able to actually reconstruct, we are actually counting how much deficiency is there for actual reconstruction. So you see that here, if we actually, this is achieved by taking the intersection, and so for example in this node we see that packet 1 and 2 can come from U2 U1 as well, so we actually one packet is so basically one node we need to subtract in order to get the repair degree. So since at most repair degree is 3 and 3 minus 1 is 2, so that is what is our repair degree in this case is 2. And I think the more detail of our paper is available at a QR code. You can just click on this and you'll get the excellent version of the paper. Thank you for watching and have a nice day.